The reason that adding and subtracting are more difficult is that you need a common denominator. So I put 4 warm-up questions for you on the paper. Remember that you cannot just add the numerators and the denominators. You need to find a common denominator and then complete your addition or subtraction. Now, a lot of times I'll do the least common denominator, which is like the smallest number that they both multiply to get to. You don't have to do that. You can do any common denominator as long as you simplify at the end. So I'd like you guys to go ahead and try these 4 examples to see if we can remember how to add and subtract just regular fractions. And then how about the last one? What do we get for a common denominator for this one, Sam? 180 was the common denominator. Again, a lot of you might just get sick of trialing and erroring and just multiply by 45 and 12 just to get it to work. But this one, if we multiply by 15 and we multiply this by 4, we will get 180 as our common denominator. So this was 165 over 180 minus 28 over 180, and when we subtract those, we will get 137 over 180. Now, I hope that you all know how to add and subtract fractions. I do want to show you, though, because some students say I never knew this. Your calculator could do every single one of these questions for you. So if you wanted to, or if you're someone who struggles with fractions, and even just to help you on the SAT, if this was the calculator part, I'd just like to show you, even though we should all know how to do these things by hand, just like we did, you can type this expression in your calculator using parentheses and division. So 11 twelfths, we would put parenthesis 11 divided by 12, close your parentheses, that's 11 twelfths, minus parenthesis 7 divided by 45. And parenthesis, hit enter. We get a decimal. Convert that back to a fraction by pressing your math fraction button. Done. Okay, so just so you know, in case that would ever come up and you're struggling or whatever, that's not going to necessarily help you at all with what we're doing today, because we're going to have algebraic expressions like c plus 2 in the denominator. Your calculator doesn't do those, but this would help with just regular numbers. All right, so this little activity, it's really not an activity, but they want us to add or subtract and simplify where possible. So can I add these 2 fractions together? Do they have a like denominator? Yes. So we would add the tops, 2 plus 3, which is 5. Again, the common denominator would stay common. You do not add those and make it 2x, it would just stay x. Now the next one, we do also have common denominators. Oops. But this one is subtraction. What would I get whenever I subtract and simplify for this one? Because I am subtracting 2 things. I'm subtracting x and I'm subtracting a negative 3. So what should I get when I simplify that? Hello? Do we know how to subtract? Should. Distribute your negative. Simplify. 4 plus 3 is 7. Can we cross off the 3 x's? Abby? Good. No, the top is the binomial. There's imaginary parentheses grouping a binomial together. Okay, and that's because the inverse of subtracting is not dividing. It would be addition. So you really need a plus 3x in order to cross off the 3 x's or cancel them. Okay, so just be careful if you are subtracting 2 things that you would distribute your negative to before you combine your like terms. And if you wanted, you could write this as negative 3x plus 7. It doesn't matter which order. Now the next one, we also have common denominators. Adding is easier though, because you can just add the like terms together. So we should get 8c plus 1 over 2c minus 1. and we cannot cancel anything out here, even though like these have a common factor. We can't take an 8 out of the whole binomial, so that cannot be simplified any further. So explain the steps you followed in question 1. We added or subtracted the numerators. And kept the denominators the same. How is it the same as adding rational expressions to adding fractions? You need a common denominator. Now the denominators aren't going to be just numbers, they're going to be algebraic expressions. So they have x's and y's, they may have parentheses. Okay. So on the front here, we're just going to review how to find the least common multiple of algebraic expressions. And then on the back, today we are doing like the easy problems where they aren't super long yet, but tomorrow will be our hardest day where we'll have to do a lot of work to get a common denominator and then a lot of work to simplify our final answers. But I split it up to make it not so challenging the first day. Okay, so to add or subtract rational expressions with unlike denominators, you can write the expressions with the least common denominator, which is called the LCD. Which is actually the least common multiple, LCM, of the denominators. So you may remember back in Algebra 1 finding the GCF and the LCM of numbers and expressions. So there is actually like a way to find the LCM. Most of you will just think it in your head. Like, what's the smallest number that 4 and 6 both multiply to get to? What would it be? It's the smallest number that both 4 and 6 could multiply to get to. And what's the least common denominator? Lexi? 12. Okay, so if you can think of that, you can just write 12. But the way to actually find it if the numbers were larger is you would do what's called the prime factorization of each number. So you break this down into 2 times 2, and you would break this down into 2 times 3. And then usually you'll rewrite it in exponential, so this would be 2 squared. This would just be 2 times 3. And then the least common multiple, you will take the greatest exponent of common factors and all non-common factors. Again, the majority of you aren't going to have to actually do this. You can just think it through in your head what the LCM is. But you will take between the common factors, so these are common factors, 2 squared and 2. You'll take the bigger of the exponents. So this is 2 the first, this is 2 squared. So we're going to take the bigger one, which is 2 squared. And we have to pick up all non-common factors. So you also have to pick up the 3. And then 2 squared is 4, 4 times 3 is 12. Now the same thing works with if we add in numbers. So this would be 2 squared times x, and this would be 2 times 3 times x squared. So the same thing, any common factors that we have, so we have the 2's in common, you take the bigger of the exponents, so this would be 2 squared. And we also have x's in common. We take the larger of the exponents, x squared, and you pick up any factors that are remaining, so 3. So this will be 12 x squared. Again, you do not have to do all of this work, but this is the way that, for those of you that would struggle with like the 12 and the 45, you could find the prime factorization of 12, which would be 2 squared times 3, and then the prime factorization of 45, which would be 3 squared times 5, and then you would follow this process to find the least common multiple. All right, find the LCD, which is the least common multiple of the denominators, so least common denominator of each pair of expressions. So you're only looking at your denominators. Again, a lot of you can do this without listing. The easiest way to think of it is 6 times 2 is 12, 6 times 3 is 18. Well, 9 times 2 is 18, so 18 is the least common multiple. That's your answer. But if you don't want to think, you can do the work, which would be to list the prime factorizations. You would take the bigger, these are in common, you'll take the bigger one, which is 3 squared, and you'll take any non-common factors as well, which will get me my 18. See if you can try B and C, finding the least common denominator. And how about for C? Sam?
39 equals C.
Perfect. And you're taking the larger exponent that they have in common from b to the cubed and b to the first. All right, so on the back, what we're going to do is we're going to add or subtract expressions that don't have common denominators. So we're going to have to find a common denominator and rewrite it, and then add or subtract the numerators. So like we did in the bell ringer, however, the denominators are now going to have algebra in them. Okay, these are easy ones because it's monomials only. The harder ones will be when we have binomials and trinomials, or polynomials of 4 terms in the denominator, where we have to factor it and then find a common denominator. So the steps are typed out at the top. You're going to find the LCM of the denominator. You're going to rewrite each expression using the least common denominator, and then you'll add or subtract the numerators and simplify. So again, most of you don't have to do all the work that we did on the front, but if you do, and I should say, you don't have to find the LCM. You could just find a common denominator. It doesn't have to be the least. So just like Ashley told us on the bell ringer, when in doubt, just multiply by the other denominator, and that will get you a common denominator. So for this one, you could just multiply this by 6 and multiply this by 3x. It would work. You'll just have to simplify at the end. But the least common denominator between 3 and 6 is 6, and we'd need to have a 6x. So the least common denominator would be 6x. So to make this become 6x, I'd have to multiply by 2. Whatever you do to the denominator, also do to the numerator. The other fraction just needs to be multiplied by an x. So I will get 4 over 6x plus 1x over 6x. Now notice the numerators, I'm going to add these together. I cannot combine them because they're not like terms. So I'm just going to get x plus 4 over 6x. And you'll be happy to know the homework doesn't ask you to state restrictions. Now, if you were to do the non-least common denominator, so let me just show it. So if you were to multiply this by 6 and multiply this by 3x. So if you just found a common denominator. Whoops. You would end up getting 12 plus 3x over 18x, and most of you would probably make the mistake of leaving your answer like that. It needs to be reduced, so you would then factor the top, factor a 3 out of there, and then you would be able to reduce the 3/18 to be 1/6. So if you prefer, you can just find the common denominator, but you will have to do more simplifying at the end. All right, the next one, what would my least common denominator be amongst these two? What would the LCD be? Okay. Yes, 21y to the 4th. So this one will multiply by just a 3 on the top and bottom. This one will multiply by 7 and y to the what power? To get it to be y to the 4th. Sam?
Squared.
Yep. So this will get me 9 over 21y to the 4th plus 14y squared over 21y to the 4th. And again, we cannot actually combine these, but we can write them together over one fraction. which would be 14y squared plus 9 all over 21y to the fourth. See if you guys can try the next two, and then we'll take a look at when the denominators are not monomials, but they are binomials. And then 15 and 36 have what factor in common? That's divisible, Ashley? 3. So you can reduce this by a factor of 3 and reduce that by a factor of 3. So that's how we would get 5b plus 1 over 12b squared. And then again, you can distribute the 5 back through, or you can leave it out. I don't care. So if you want 5b plus 5, or 5 times the quantity b plus 1. All right, now the last ones, some of you will actually find these easier, have binomials in the denominator. Remember that these are actually grouped. All of these have imaginary parentheses around them. Now on your homework, look, because if they are the same binomial, you already have a common denominator and you can just add or subtract. That can sometimes happen. But if you want to make a common denominator with binomials, you are literally just going to multiply by the other one, typically. So for this one, I'm going to need to multiply, and I'm just going to rewrite it so I have some space. I need to multiply this one by c minus 3, both in the numerator and the denominator, to get it to have a common denominator. Plus 6 over c minus 3. I need to make this one have a c plus 2, so I'll multiply it by c plus 2 in the denominator and the numerator. Up top, we have to distribute. And you can write one big fraction after this, so that you don't have to rewrite two separate fractions. So this will be 5c minus 15 plus 6c plus 12, make sure you distribute, all over our denominator, that's common, c minus 3c plus 2. And then we can combine our like terms to get 11c minus 3. You do not need to FOIL the denominator, so just leave it factored. Again, some of you will like this better because it doesn't take you as long to figure out what the least common, you just multiply by the other denominator. So for this next one, I'm going to multiply by t minus 1 in the top and the bottom for this fraction. This one I'm going to multiply by t plus 4 in the top and the bottom. And make sure that we distribute that. So we'll have 5t minus 5 plus 3t plus 12 all over our common denominator. And then just combine your like terms. We'll get 8t. 12 minus 5 is 7. If we could take a GCF out of the top, we would, and then see if anything would cancel, but that's really it. Now, I didn't put any subtraction ones on here, so just be careful on the homework. There may be a subtraction one where you'll have to just, whenever you subtract, you would distribute like a -3 instead of a +3. But see if you guys can try the last two really quickly. We'll just skip the closure. So most of you could probably figure that out on your own. Let's let these two be your closure.